Hello to each and every one of you. Welcome back again into our lesson video. So today we're going to be looking at life sciences, grade 12. So grade 12, specifically we're going to be looking at nervous system. Okay, yes, I've been trying to look for a question paper that is going to at least make you to understand the concept of, or the fundamental concept of nervous system as a whole, as a topic in life sciences. Okay, so I think I found the question paper, so we're going to be doing this question paper. Okay. Okay, so you have, okay, so also then please don't forget to subscribe to the channel for more lesson contents, right? Yes, please subscribe now to the channel. Thank you so much for subscribing. Thank you. Okay, so we have the central nervous system. Okay, yes, so this is the central nervous system, your brain and spinal cord, and you have other organs such as your motor neurons or your neurons, etc. Okay, yes, as well as your connector neurons, the sensory neurons, and as well as your effectors, which can be organs in your body, okay, that are being affected, okay, in terms of response. Okay, okay, now we also have the key. Okay, so the key shows the letters A, B, E, and F. So we have A, the blockage at A. So A shows the blockage. So each and every letter there shows the blockage, where the blockage is. So B, the blockage is at B. As you can see, E, the blockage is at E, and F, there is no blockage at all. So F, there's no blockage. So you can see that there is no F there. Okay, okay. Now let's go to our questions. So our question says 1.4.1, write down the correct letter for each segment using the key given in the diagram above. Okay, meaning that in this case now we have to answer our questions. Okay, we have to answer our questions. We have to write down the correct letters for each statement using the key given in the diagram above. So we have to answer these questions, okay, in relation into which letter do you think the blockage is at. Okay, yes, so if at A, you think by reading A, the statement at A, if you understand that, okay, the blockage, I think it's at E, you can just write A, E. Okay, yes, but I'll explain everything, right? Yes, so A says when the skin of the thumb is stimulated. Now the skin of the thumb is stimulated, the thumb and the hand move involuntarily. Okay, and they move mean that they respond, they move involuntarily, they move very in a high speed. Okay, yes, in terms of response. So but the patient cannot move the hand voluntarily or feel it move. Okay, yes, so which letter do you think there? Okay, so let me explain through the diagram so that you can fully understand the answer. So when the skin and the thumb is stimulated, stimulate the skin and the thumb, means that it's around maybe dangerous environment like heat, next to the stove, very hot stove, and so on. Or maybe you just touched your thumb into a very hot stove. So what happens now? The thumb and the hand move involuntarily, meaning that the sensory neurons send the impulses or messages to be integrated in the central nervous system, where specifically in the spinal cord, but not in the brain, because it moved involuntarily, meaning that the impulses were integrated in the spinal cord and sent back instantly to the effectors, which is your thumb, so that it can be moved. Because it's going to take a lot of time if ever it sends the impulses to the brain and also be integrated in the brain back to the spinal cord and so on. So the thumb is going to bend. So that's why when you feel or you're in dangerous environments like heat, etc., or being pinched, etc., like things like that, like you move very quickly or you respond very quickly. So that's how it goes. So, but the patient cannot move the hand voluntarily or feel it move, meaning that they just can't move it voluntarily and feel it move, meaning that there is no blockage at E because the impulses were sent back, and there was no blockage at B because the impulses were sent to the spinal cord, meaning that the blockage is at A. Okay, is at A, the blockage is at A, meaning that the impulses were not sent to the brain. That's why it's a involuntarily action or movement. Okay, I think you get it. You get it, guys. That's how it goes. Okay, so at B, the patient can feel the thumb being touched or pinched. So now let's erase that. So now the patient can feel the thumb being pinched or touched. Okay, yes, so sorry. They can feel it. Okay, when you feel it, meaning that you have sense in your brain that okay, there's something that is going on, meaning that the impulses were sent, okay, to the central nervous system, more especially to the brain. Okay, yes. So the brain integrated the information and told you that okay, Sisipo, now what's going on? Your thumb is being touched. Okay, meaning that the brain started to send back, meaning that you have some sense. That's why I emphasize sense. Okay, you have some sense that you are being touched or pinched. Okay, you know, that's the information that you have. So they were sent back, okay, via the sensory neuron. But however, you cannot move. People cannot move the thumb. They cannot move the thumb, meaning that the integrated messages or the information, yes, it's in the head, but not, it isn't transported to the effectors. So that's why they cannot move them. So meaning that the blockage is at E. There's something went wrong on the motor neuron. The blockage in this case is at E. I hope you get it, guys. Okay, let's move on. Let's move on. Try to erase everything as much as possible so that you can work very clean and clear. Okay, so let's move down a little bit. So let's, okay, we're moving to C now, I believe, right? Yes. So the patient can move the thumb. The patient now can move the thumb, but cannot feel the movement. They cannot feel the movement. Okay. They can move the thumb, but they cannot feel the movement. What does that mean? Meaning that I can just move my thumb, meaning that when I'm doing some specific activity, let me make an example when you're running. When you're running, your organs are moving. Like many organs that you have in your body are moving, and you can feel that they are moving. Meaning that your impulses were sent to the brain and integrated and back and sent back via the motor neuron to those effectors or to those organs so that they can feel that okay, I'm moving and I can feel that this thumb is moving. But now the thing is that the patient can move the thumb. Let's say for example this patient is running, but now the thumb is moving while they are running, however, but cannot feel the movement, meaning that if they cannot feel the movement, the impulses were not sent to the central nervous system so that they can integrate, so that they can be integrated or interpreted. Okay, yes. So if that's the case now, meaning that the blockage is at B, because the neuron that is responsible for sending the impulses to the central nervous system is what? It's sensory neuron, and the sensory neuron is being blocked there. So the blockage is at B, and that's how it goes. Okay, yes, that's how it goes. I hope you get it, guys. Let's move on. So let's move to number T. Number T says when the skin of the thumb is stimulated, okay, the skin of the thumb is stimulated, okay, is receiving some environmental conditions, so the thumb moves, okay. When it is stimulated, the thumb moves. Let's say I'm pinching this thumb, okay, of this patient, so the thumb can move, meaning that the impulses were sent to the central nervous system and back to the effectors. Okay, yes, and the thumb moves and the patient is now, it is moving. Okay, meaning that it was sent to the central nervous system, and that includes the brain, guys. Okay, yes, that also includes the brain. Let me just make a diagram for you so that you can understand. So thumb can feel that being pinched, meaning that the impulses were sent to the brain. So it's the brain that told you that your thumb is being pinched. So, and it has responded by, meaning that you moved your thumb, meaning that the motor neuron has sent back the integrated messages, or the interpreted messages to the effectors, so that, hey, effector, there's something going, okay, yes. So meaning that if you can see our blockages, the message is passed at A, message is passed at B, message is passed at E. There's no blockage here, meaning that the answer is F. Okay, yes. So for T, the answer is F, and that's how it goes. Okay, okay. So now let's move to 1.4.2. So 1.4.2 says that which lipid part of the central nervous system will be actively involved to generate a quick response in normal and healthy person when the thumb accidentally touches a hot surface. Okay, which the question, by the way, is basically asking us which part of the central nervous system, meaning that the part of the central nervous system, our central nervous system comprises of the brain and the spinal cord. So which part is responsible for what? Let me go and analyze. For quick response is the spinal cord. I told you guys, is the spinal cord. So meaning that this is whereby your messages are being sent to the spinal cord, not to the brain, because if ever they're sent to the brain, there will be more damage that is going to happen to your organ. So, and it's going to be sent quick back to the effectors from the spinal cord, okay, as a quick response. And that's how it goes, so that you can instantly move, or move quickly, or respond quickly. Okay, yes, that's how it goes. I think you get it, guys. Okay, so let's move to 1.4.3. 1.4.3 says name the type of reaction that has been mentioned here. What's the type of reaction? We call it a reflex action. Okay, we call it a reflex action, and that's how it goes. And please, guys, don't confuse the reflex action and a reflex arc. A reflex arc is a representation of the nervous system, okay, due to this type of response, which is reflex action. Okay, yes, this is why you're going to have in a reflex arc, you're going to only have the spinal cord, not the brain. Okay, yes, the spinal cord, your impulses that are being sent, and the impulses that are being sent back. The impulses that are being sent, mind you, are going through via sensory neurons and are unintegrated messages, and back is your motor neuron, meaning that the the neuron that is responsible for taking back the integrated messages from the central nervous system to the effectors is known as the motor neuron, and that's how it goes. Okay, let's move down, guys. I think you get it. Let's move down. So number 1.4.4 says which two parts shown in the diagram are protected by meninges? What parts are protected by meninges in this instance here? So the parts that are being protected by meninges here is your um, it's your brain and the spinal cord, right? Yes, it's your brain and spinal cord. So meaning that the meninges are the, I can say, are the membranous layers, okay, between the skull and the brain, and between the vertebra and the spinal cord. Okay, yes, so that they can reduce the friction as well as the injuries. Okay, so those are the membranes that protects the brain and the spinal cord. So meninges, that's the function of the meninges. Okay, yes, okay, I think you get it, guys, and that's how it goes. Okay, yes, that's how it goes. Okay, so now let's move now to, I think, the last question, I believe, which is 1.4.5. So 1.4.5 says identify the letter representing the peripheral nerve that is composed of sensory neuron. Okay, so we have to pick up the letter that shows the sensory neuron, A, and B, the motor neuron. Let's go. I already told you while explaining. So C, letter C shows the what? The sensory neuron. And T shows the motor neuron. So what's the difference between C and T? Which is, what's the difference between motor neuron and sensory neuron? So let me start with the sensory neuron. A sensory neuron is a neuron that is responsible for sending the information, or no, not the information, the impulses or the messages which are unintegrated specifically, okay, to the central nervous system so that they can be integrated. And the motor neuron sends back these integrated messages as the information back to the effectors. For example, if I touch you on your shoulder, the impulses, so meaning that that stimulus is going to be converted, okay? Yes, it's going to be converted to become a what? It's going to be converted to become impulses. And those impulses are going to, meaning that your muscles are going to at least convert those, okay? Yes, into impulses, your muscles on your shoulder. After that, the sensory neuron is responsible for taking these impulses to the brain, okay? Now you haven't felt that you are touched or you don't know. The brain is going to integrate what's going on very quick as the central nervous system organ, okay? Yes. So the brain now knows, okay, you are being touched. And the brain is going to tell you that you are being touched and give you the information. But you haven't yet felt in your shoulder, okay? And we move on. So the brain is going to send back this integrated information via the motor neuron down the spinal cord, okay? Down the spinal cord, back to the effectors, which is your shoulder, for example, okay? And you can feel that, oh, I'm being touched now, okay? But it happens very, very quick and fast, okay? Yes, and that's how it goes. So that's the difference between the sensory neuron and motor neuron. Sensory neuron sends the impulses to the central nervous system, and the motor neuron sends back the integrated messages or the information from the central nervous system to the effectors, and that's how it goes. And that's it, and that's the end of our lesson video today, guys. Okay, please don't forget to subscribe for more lesson contents. Okay, yes. See you in the next one video. Have a great day. Cheers. Bye.